Hello and welcome. It's your main math man, Mr. Lyons here, and we are multiplying and dividing numbers in scientific notation today. And I personally find this simpler than adding and subtracting in scientific notation. And you'll see why. You should have seen why up here. Because when you're multiplying factors, when you're strictly multiplying, just multiplying everything, it doesn't matter the order because you can use the commutative property. That's right. So here we have 3.6 times 10 to the 9th times 7 times 10 to the 5th. Since we're multiplying here, we can use the commutative property. We can also write this as 3.6 times 10 to the 9th times 7 times 10 to the 5th, right? Everything here is a factor. Everything here is being multiplied. Unlike adding and subtracting, when you're adding scientific notation, you can't just put them in any order. But since we're multiplying everything here, we can actually just take and multiply our what? What do you think would be useful here? What do you think would be efficient here if we multiplied our what first? That's right. If we grouped together our leading factors, and then we group together our powers of 10. Right? The order doesn't matter when you only are dealing with factors and you're multiplying factors here, right? What's 3.6 times 7? I don't mind if you use a calculator for this. I'm just going to review very quickly how to multiply decimals. I mean, yeah, you don't need to line up your decimals when you're multiplying. That's why I personally find it a little easier. But you do turn them into whole numbers, right? You have to move your decimal over once. You have to move your decimal over here 0 times. I hope this is making sense. If you want to use a calculator, feel free to use a calculator. I don't mind. I just want to show you how to do this here. 7 times 6 is 42. Regroup here. 7 times 3 is 21 plus 4 is 25. We moved our decimals a total of 1 time. So we're going to move our decimals over back 1 time. Check your calculator. Trust me. Believe in me. All right. So here we got 25.2. And I feel like we know how to do this, right? Brian, this is your rule here. When multiplying exponential expressions that have common bases, you can add the exponents. That's right. So it's going to be times 10 to the 14th power here. So a lot of kids will say, oh, this is my answer. Actually, this is not quite your answer yet. Why is this not your answer? It's the leading factor for me, right? So we're going to have to make our leading factor bigger or smaller. We're going to have to make it smaller by a place value. But we're not just throwing that in the garbage. We have to give it to our power of 10 here, right? So now I'm going to have 2.52 times 10 to the 15th power as my final answer. Bada bing, bada boom. Right? This is why I find multiplying scientific notation a little easier than subtracting. Let's take a look here. Now we're finding the quotient. Here we're finding the product. We're multiplying. Here the quotient, which means we're dividing. Yeah. So, right, this is like shoot, reduce, just like when you think about fractions here. You can rewrite this even as a fraction if you want to break it down a little bit. This would be 8 over what times 10 to the 4th over what, right? This is 8 over 1.6 times 10 to the 4th power over 10 to the 7th, right? That's how that works. So you can easily just divide these guys here, right? What is 8 divided by 1.6? Use your calculator, please. What's 8 divided by 1.6? You should have gotten 5. And I feel like we know how to do this part right here, right? 8 divided by 1.6 is 5. What is 10 to the 4th divided by 10 to the 7th? This is your rule, the quotient rule. When dividing exponential expressions with common bases, all right, when dividing, though, we're not going to add here like we did here. We're going to, that's right, we're going to subtract. What is 4 minus 7? It's not 3. It's actually negative 3. Now, this answer is okay because this answer is indeed in scientific notation. Our leading factor is between 1 and 10. We have a power of 10. Bada bing. Bada boom, right? It's literally quite that simple, multiplying and dividing numbers in scientific notation, okay? What you're going to do now is you're going to think about what we just did. On the next slide is fill in the blank, so you don't have to come up with these words on your own, but on the next slide, do the fill in the blank, and then you'll have the answers to fill this in, okay? If you think you can do it by memory and you think you know what goes in here, go ahead and get after it. But on the next slide, do the vocabulary, then you're going to fill this in, and I'll check you later.